The sky is a bruised gray, and the ocean is a churning mass of white water. A drone cuts through the gale, its rotors fighting the wind until it reaches the edge of the storm. It dives. The white foam vanishes as the camera plunges into the dark, cold blue of the abyss. There, anchored in the silence of the deep, a massive geometric steel fortress rises from the gloom. Thousands of silver shapes circle within the cage, moving in rhythmic, synchronized pulses. By 2050, the world will face a wall of scarcity, requiring 70% more food than the planet can provide. With the soil exhausted and wild fisheries collapsing, the old ways of farming have reached their limit. We are no longer looking to the fields for survival. We are looking to the depths of the open ocean. This structure is not just steel and mesh, it is the first anchor of a new frontier. Human ingenuity has descended into the pressure and the dark to build a solution that land can no longer sustain. The future of food has left the soil behind, descending into the crushing weight of the sea to find a way to feed the world. Traditional coastal farms were fragile, failing whenever pollution spiked or currents stalled. They were at the mercy of the surface, exposed and stagnant. The new deep-sea cages solve this by abandoning the shallows entirely. Miles offshore, these megastructures operate in the open water, where the ocean is vast enough to dilute any impact, but the surface remains a volatile place. When violent storms turn the waves into mountains, the steel frame does not resist the force. It vanishes. Operators trigger the ballast tanks, and the massive structure begins its descent. It sinks 100 feet, slipping past the turbulence of the wind-whipped surface into the calm, stable currents beneath. Down here, the water is quiet. The storm rages above, but the fish remain in a zone of absolute stability. This is the engineering of evasion. By moving vertically, the structure outmaneuvers the chaos of the weather. It is a precise, calculated retreat that keeps the food supply intact when nature is at its most destructive. The frame locks into the deep, waiting for the surface to settle before it ever considers returning to the light. Managing millions of fish in a pressurized environment requires more than steel. It requires a digital brain. Stereoscopic cameras line the interior of the pens, recording every movement 24 hours a day. High-speed processors analyze the footage, using advanced biomass software to calculate fish weight and health in real time. No human hands touch the stock. Instead, an automated barge hovers nearby, pumping precise ratios of feed through underwater tubes based on the data stream. The margin for error is non-existent. Deep beneath the surface, sensors constantly pulse, monitoring dissolved oxygen and salinity levels. A sudden shift occurs. A subtle drop in oxygen saturation triggers an immediate alarm within the central server. Without human intervention, the system instantly activates aeration valves. Bubbles erupt from the cage floor, restoring the balance before the ecosystem can collapse. It is a constant, invisible negotiation between biology and code. Every millisecond of data is a safeguard against failure. The facility maintains its own life support, a self-contained cycle that relies on constant calibration to survive. If the digital brain falters, the entire population is at risk, but the system holds, keeping the volatile environment perfectly tethered to life. The final cycle begins with a command from the surface. The deep-sea fortress, once anchored in the quiet pressure of the abyss, initiates its ascent. Winches engage, and the massive steel frame rises through the water column, shedding the dark weight of the depths. As the structure breaks the surface, the water inside the pens churns with the movement of thousands of silver salmon. There are no trawling nets here. There is no dragging of the seabed or indiscriminate capture of the local ecosystem. Instead, a wellboat pulls alongside the cage. A pressurized, liquid-pumping vacuum is lowered into the center of the structure. It creates a seamless conduit between the pen and the vessel. With a sudden, rushing roar, the fish are drawn upward, suspended in a continuous stream of water. They move instantly from the cage into the chilled, oxygenated tanks of the waiting ship. The transfer is rapid, gentle, and precise. It is the ultimate triumph of the engineering model, a clean extraction that leaves the surrounding ocean untouched. In minutes, the cage is emptied, the structure is sanitized, and the vessel departs. The cycle is finished. The harvest is complete, achieved without a single net touching the wild floor of the sea. Beneath the site of the harvest, the ocean floor remains untouched. Where traditional coastal farming once left behind layers of silt and chemical runoff, these deep water currents act as a natural, relentless cleaning engine. The waste is diluted into the vastness of the abyss, vanishing before it can alter the local chemistry. There is no scarring of the seabed, no depletion of wild habitats. The ecosystem beneath the cage breathes as if the structure never existed. This is the cornerstone of the Blue Revolution. By moving production into the deep, humanity has decoupled food production from the limitations of the earth. The soil is no longer the primary provider. Instead, the open ocean, once considered a barren void, now functions as a high-yield, sustainable engine. It is a fundamental realignment of our relationship with the planet. As the vessel sails toward the horizon, the facility resets for the next cycle, a quiet sentinel in the deep. The world's growing demand for food has found its answer in the pressure and the currents of the abyss. The frontier is no longer on land. It has migrated beneath the waves, securing a future where the harvest is as infinite as the sea itself.